Hari Om. Hello everyone, I am Shri Jyoti. Welcome back to my channel. Today's video is of class 12 mathematics chapter 12 linear programming problem or LPP. In class 11th we studied linear inequalities and finding the solutions by graphical method. So in this chapter we will apply these systems of linear inequalities and find the solutions by graphical method. But linear programming problem is a method to find the optimal solution. Optimal means maximum or minimum. That is, here we will find maximum and minimum values of the linear function. That is, here we know that in our daily life we have come across with the problems which seeks maximizing the profit or minimizing the cost. So such problems are called optimal problems. That is, linear programming problem is a technique to find the optimal solution. So in this chapter we will apply this concept to solve the real life problems. For example, let's go through an example. Anil is a retail fruit seller. He has rupees 500 to buy apples and grapes. In the shop, he has a space to store at most 12 boxes of fruits. The cost of a box of apples is rupees 25 and a box of grapes is rupees 50. Anil sells the apples at a profit of rupees 6 per box and grapes at a profit of 10 per box. He can sell all that he buys. Here, if so, let's find the number of boxes of apples and number of boxes of grapes that he should buy and sells to get a maximum profit. Okay, here we will find the number of boxes of apples and grapes that he should buy and to get maximum profit, sells to get maximum profit. Okay, so here, so for our convenience, see, first of all, here we have to transform this problem into mathematical form. Okay, so for that, for our convenience, let's take, let x be the number of boxes of apples and y be the number of boxes of grapes and z be the profit. Okay, x be the number of boxes of apples, y be the number of boxes of grapes and z be the profit. Okay, so here first of all let's write the profit. Okay, what is the profit? Z, right? Profit is z. Z is equal to, see here it is given, Anil sells the apples at a profit of rupees 6 per box. That is, here for one apple box he sells, okay, he sells for rupees 6. Okay, that is how many apple boxes are there? Total there are x number of apple boxes, right? Therefore, what is the total profit for only apple boxes? That is 6x, right? Because he sells apples at a profit of rupees 6 per box. Okay, so therefore z is equal to 6x plus, then what about grapes? And grapes at a profit of rupees 10 per box. So how many boxes are there? Y boxes, right? So y 10y. There are how many boxes? Y number of grapes boxes. Okay, therefore his total profit is 6x plus 10y. Okay, z is equal to 6x plus 10y. Next, see here, what is the total cost? Here, the cost of a box of apples is rupees 25. Okay, for one apple box, rupees 25. How many apple boxes are there? X, right? Therefore, total cost is 25x plus, next, what about grapes? And a box of grapes is rupees 50. For one grapes box, rupees 50. So, how many grapes boxes are there? Y, right? So, Y boxes are there. So, 50Y. And see, it's very important, he has rupees 500. Therefore, here this total cost cannot be more than 500 because he has only rupees 500. So, how to write? The total cost 25x plus 50y less than or equal to 500 because he has only 500 rupees. Therefore, the total cost should not be more than 500. Okay. So, therefore, we can write 25x plus 50y less than or equal to 500. So, reduce it. So x plus, that is x plus 2y less than or equal to 20. Okay. Next, how many boxes are there? X plus y. X is the number of apple boxes, y is the number of grapes boxes. Therefore, total boxes x plus y. And it is given in the shop he has a space to store at most 12 boxes. He has at most 12 boxes. That is, he has a maximum space to store at most 12 boxes, not more than 12 boxes. Okay. So here we can write x plus y less than or equal to 12. Because at most 12. Okay. Therefore, x plus y less than or equal to 12. And see, here we have got z is equal to 6x plus 10y and x plus 2y less than or equal to 20, x plus y less than or equal to 12. Okay. Now let's see how to formulate this problem into mathematically. Okay. How to formulate this problem in mathematically. See here. First of all, let's write. Here we will find the maximum profit, right? So maximize z is equal to 6x plus 10y. Okay. And subject to these are the constraints. Okay. X plus 2y less than or equal to 20, x plus y less than or equal to 12. And it is clear that x greater than or equal to 0, y greater than or equal to 0, right? X greater than 0, y greater than 0, because number of boxes, right? So here these are the formulation of this problem in mathematically. Let's go through an example. It's very important problem. Okay. A company manufactures two products A and B on which the profits earned per unit are rupees 30 and rupees 40 respectively. Each product is processed on two machines M1 and M2. 1 unit of product A requires 1 hour of processing time on M1 and 2 hours on M2, while 1 unit of product B requires 1 hour each on M1 and M2. Machines M1 and M2 are available at most 10 hours and 12 hours respectively during working day. Okay, the company wants to know how many units of products A and B should be produced to maximize the profit. To formulate a linear programming problem, first one, write the objective function. Second, write all constraints. Okay, see here we no need to find the number of units. Here only just write the mathematical formulation of this problem. That is objective function and constraints. Okay, so for that, see first of all let's take, here we need to find the actually how many units of, that is units of products A and number of units of product B, right? So here let's take, let x be the number of units of product A and y be the number of units of product B produced. Okay, so here and z be the profit. Okay, so first of all let's consider machine M1. Okay, in machine M1, say it is given a 1 unit of product A requires 1 hour of processing time on M1. Okay, in machine M1, product of A, okay, 1 unit of product A requires 1 hour. How many units are there? That is, x is the number of units of product A. Okay, therefore total R is, total what is the time? X into 1, x plus, next in machine M1, okay, product B. Okay, in machine M1, so first of all we are considering machine M1. Okay, so first in machine M1, product A requires 1 hour for your 1 unit. Okay, that is x plus next product B. See, 1 unit of product B requires 1 hour each on M1 and M2. Okay, we need only M1 now. Okay, so in M1 here also 1 unit of product B requires 1 hour. Okay, then total time is x plus y in machine 1. And see here, machine M1 and M2 are available at most 10 hours and 12 hours respectively. So here machine M1 is available at most 10 hours, not greater than 10 hours. Okay, at most 10 hours. Therefore, total time that should not be greater than 10. Okay, so x plus y less than or equal to 10. Okay, that is here it is the constraint of machine 1, M1. Okay, machine 1. Next is, let's consider machine 2. Okay, in machine 2, the product A, one unit of product A requires 2 hours. In machine 2, 1 unit of product A requires 2 hours. How many units are there? Product A, X units, right? X number of units of product A. Therefore, what is the total time for product A in machine M2? 2x, right? Because 2 hour per unit, right? For 1 unit of product A requires 2 hours on machine M2. Then what about product B? See here, 1 unit of product B requires 1 hour each on M1 and M2. Therefore, 1 hour, right? So, product B requires 1 hour in machine M2. Okay. So, here that is y into 1, that is y. Okay. And here see, machine M2 is available at most 12 hours. Okay. Here machine M2 is available at most 12 hours, not greater than 12 hours. Therefore, total time on M2 must not be greater than 12 hours. Okay, therefore 2x plus y less than or equal to 12. Okay, I hope you understood. That is 2x first. Here it is first of all, first inequality is about machine 1 and second inequality is machine 2. That is constraints on machine 1 and constraints on M2. Okay. In machine 1, it is mentioned here, in machine 1, 1 unit of product A requires 1 hour on machine M1. Okay. That is, here there are total number of units of product A is X. And Y is the number of units of product B. Okay. So, in machine M1, product A requires 1 hour. Therefore, X hour. Okay. X hour, total X hour for in machine M1 for product A. Okay. And product B, see, product B requires 1 hour in machine M1, right? That is 1 into Y, and that should be greater than, that should not be greater than 10 hours, because this machine M1 is available is at most 10 hours. Okay. Next is machine M2. In machine M2, product A requires 2 hours. Okay, therefore 2x, because there are total number of units of product A is X. So 2 into X plus product B requires 1 hour on machine M2. Therefore Y into 1. That's also this total time cannot be exceed more that cannot be greater than 12 hours, because this machine M2 is available at most 12 hours. Therefore, 2x plus y less than or equal to 12. Okay. Next, let's write the profit. Okay. So, profit Z is equal to, see, here it is given. A company manufactures 2 products A and B on which the profits earned per unit, okay, are rupees 30 and rupees 40. Okay. That is, for 1 unit of product A, the profit of 1 unit of product A is rupees 30. Okay. Profit of 1 unit of product A is rupees 30. There are, how many units are there? X units, right? There are X units of product A. That is X into 30. Total profit for product A is 30 into X. Okay. 30 into X. Plus, and here profit of 1 unit of product B. Okay. Profit of 1 unit of product B is 40. See, Y number of units of product B are there. Okay. That is, Y is the number of units of product B, and rupees 40 is the profit of 1 unit of product B. Therefore, total profit for product B is 40Y. Okay. Therefore, the profit Z is equal to 30x plus 40y. Now, let's answer this. See, write the objective function. Here we will write maximize. Okay. Because here we have to find the we will find the units of number of units of this company wants to know number of units of product A and product B so that they should get maximum profit, right? So here you should write maximize. Maximize Z is equal to 30x plus 40y. And write all the constraints. The constraints are x plus y less than or equal to 10, 2x plus y less than or equal to 12, and x greater than or equal to 0, y greater than or equal to 0, because x and y are number of units of product A and product B respectively. We have just learned that how to write the mathematical formulation of problems. We did not find the solutions, right? So here next we will study how to find the optimal solution of the problem. Okay, so look at this example. Consider the linear inequality 2x plus 3y less than or equal to 6, 2x plus y less than or equal to 4, x greater than or equal to 0, y greater than or equal to 0. First question, mark the feasible region. Second, maximize the function z is equal to 4x plus yy subject to the given constraints. See, mark the feasible region. See, feasible region is the region that contains all the possible solutions. From those solutions, we will find the optimal solution. Okay. So for that, see, first of all, let's write. See, we have to here also we will find the solution by graphical method. Okay. So for that, we have to find the x values, x and y values. You just substitute x and y values to draw these lines. Okay. Okay, so first of all, for that, let's take 2x plus 3y is equal to 6. Okay, to draw the graph. Okay, 2x plus 3y is equal to 6 and 2x plus y is equal to 4. Okay, then only two values are enough. Okay, put x is equal to 3, what we will get? See, when x is equal to 3, y is equal to 0, right? Put x is equal to 3, y is equal to 0. When x is equal to 0, y is equal to 2, right? So you just plot the points. See, when x is equal to 3, y is equal to 0, okay? And x is equal to 0, y is equal to 2. Then join these points, okay? Now you have got one straight line. That is, this straight line is nothing but 2x plus 3y less than or equal to 6. Okay, and next one is here. Here also you just put x is equal to 2. Okay, here x, y. Put x is equal to 2, then y is equal to 0. Right? Then put y is equal to 4. Sorry, x is equal to 0. Then you will get y is equal to 4. Now plot the points. X is equal to 2, y is equal to 0. Okay, this is the point. Then x is equal to 0, y is equal to 4. Okay, I was mistaken. Okay, you take this, it is the 4. Okay, so here 0, 4. Okay, then join the points. So here it is the line 2x plus y less than or equal to 4. Okay. And here we have to mark the feasible region. First of all, we have to mark the feasible region. Feasible region is the region which contains all the possible solutions. Okay. So here this inequality less than or equal to, right? So here we know we have studied in 11th standard to find the solutions by graphical method, right? Inequalities, linear inequalities. So here see less than or equal to means it is the region. Here this line less than or equal to and this line less than or equal to. So it is the region, feasible region where the solution contains. Okay. So here see, this is the feasible region and what are the points contains here? See, these are the solutions. Okay. So let's find, it is nothing but 0, 0. Right? It is the points. What are the points? 0, 0. And it is the point 2, 0. Right? And it is the point 0, 2. Then this point. We have to find this point. See, this point is nothing but it is the intersection of these two lines. Right? So by solving these two equations, we will get these 2 point, this point. Right? That is 2x plus y is equal to 4 and 2x plus 3y is equal to 6. By solving these equations, we will get x and y values. Right? See, 2x is equal to 4 minus y. Right? Substitute this 2x here. So 4 minus y plus 3y is equal to 6. That implies 4 plus 2y is equal to 6. That implies 2y is equal to 6 minus 4, that is equal to 2. This implies y is equal to 1. Substitute y is equal to 1 in any of these equations to get the x value. Okay, so 2x plus 1 is equal to 4. That implies 2x is equal to 3. That implies x is equal to 3 by 2. X is equal to 3 by 2, y is equal to 1. It is the point 3 by 2, 1. Okay. So 3 by 2, 1 is also a solution. Okay. Now we have to find the optimal solution. Right. That is maximum value, maximum profit. So at which point it is maximum, that we have to find. So here for that, see, let's consider all these points. Take one by one. First of all, 0, 0. Then here z maximum, that is, what is the equation? Z is equal to 4x plus 5y. Right? Substitute x is equal to 0, y is equal to 0. What is z? 0. Right? Next, let's take 2, 0. Okay, 2, 0. Substitute x is equal to 2, y is equal to 0. That is 4 into 2, 8. Next, let's substitute 0, 2. 0, 2. Z is equal to, put x is equal to 0, y is equal to 2, that is 10. Next point is 3 by 2, 1. So z is equal to, put x is equal to 3 by 2, so 6 plus 1, that is 6 plus 5, 11. Okay. Put x is equal to 3 by 2, y is equal to 1. So here we will get z is equal to 11. See, here z is equal to 11 is the maximum. Right? Z is equal to 11 is the maximum. So here at which point? At this point. That is, when x is equal to 3 by 2 and y is equal to 1, this z is maximum. Okay? This z is maximum when x is equal to 3 by 2, y is equal to 1. It is the solution. Okay? Optimal solution. So, here z is maximum. What is the maximum value? 11. Okay? So, let z is maximum at the point, what is the point? 3 by 2, 1. Or we can say, when x is equal to 3 by 2, y is equal to 1, z is maximum. Okay? And maximum value is 11. Now let's go through exercise 12.1. First question, solve the linear programming problem graphically. Maximize z is equal to 3x plus 4y subject to the constraints x plus y less than or equal to 4, x greater than or equal to 0, y greater than or equal to 0. Here objective function and constraints are given. Okay. Here we have to find the optimal solution. That means we have to find at which points, at what values of x and y this given z is maximum. And what is the maximum value of z. Okay. So let's find. See, first of all, here we have to find the solution by graphical method, right? So first of all, here let's take find the values of x and y to draw this graph. Okay, so here x plus y, to plot the points we have to take x plus y is equal to 4. Okay, then x is equal to x and y. Put x is equal to 0. What is y? 4, right? Put y is equal to 0. What is x? 4, right? So two values are enough. Okay, so here x is equal to 0. It is the point 0 origin. Okay, x is equal to 0, y is equal to 4. And when x is equal to 4, y is equal to 4, y is equal to 0. It is the point. Okay, when x is equal to 0, y is equal to 4, it is the point. When y is equal to 0, x is equal to 4 is this point. Then join these points. Okay, so it is the line x plus y less than or equal to 4. Therefore, feasible region is inside this line, right? That is, it is the feasible region. Okay, and what are the possible solutions? See, these are the points, corner points 0, 0, it is 4, 0, 0, 4, right? 0, 4, 4, 0, 0, 0. So here we have to find at which point the given z is maximum. Okay, so for that let's find points, and z is equal to 3x plus 4y. Okay, what are the points? 0, 0. Substitute, put x is equal to 0, y is equal to 0. We will get z is equal to 0. Next is the point 4, 0. Okay, see, first of all you have to find what are the possible points. Okay, corner points. See here 0, 0 and it is 4, 0, it is 0, 4. It is the feasible region. Okay, so 4, 0. When 4, 0, here put x is equal to 4, y is equal to 0. So 12, z is equal to 12, right? And next is 0, 4. That is, put x is equal to 0, y is equal to 4. So z is equal to 16. See here, maximum value of z is 16 at which point? At 0, 4. Okay. So here we can write maximum value of z is 16 at 0, 4. Okay, that is when x is equal to 0, y is equal to 4. So it is the answer. Look at the next question. Here also we have to find the solution by graphical method, and minimize z is equal to minus 3x plus 4y subject to x plus 2y less than or equal to 8, 3x plus 2y less than or equal to 12, x greater than or equal to y greater than or equal to 0. Okay. So here also we have to, here objective function and constraints are given. Okay, we have to find when z is minimum. For what values of x and y z is minimum, that we have to find. So for that, to draw the graph, we have to consider these two constraints, that is x plus 2y is equal to 8 and 3x plus 2y is equal to 12. Here x and y, first of all put x is equal to 0. Okay, what you will get? Y is equal to 4, right? Next put y is equal to 0, you will get x is equal to 8, right? Then see, x is equal, it is the point origin 0, 0, it is 0, 0, and when x is equal to 0, when x is equal to 0, y is equal to 8. Sorry, when x is equal to 0, y is equal to 4. It is the point. Okay, and when x is equal to 8, x is equal to 8, y is equal to 0. It is the point. So join these points. Okay, so first of all plot the points. See, for plot the points we have to find the x and y values. Okay, so here 0, 4, 0, 4 and 8, 0. Okay, join these points. So it is the line x plus 2y less than or equal to 8. Okay, next here 3x plus 2y is equal to 12, x, y. Here also put x is equal to 0. What is y? 6. And put y is equal to 0. What is x? 4. Right? Okay. Now plot the points. 0, 6. Put x is equal, when x is equal to 0, x is equal to 0, y is equal to 6. It is the point. Okay. Then x is equal to 4, x is equal to 4, y is equal to 0. It is the point. Then join these points. So this straight line is 3x plus 2y less than or equal to 12. Okay, and here see both the equations, it is less than or equal to, inequality less than or equal to, therefore the feasible region is inside this one, right? So here it is the feasible region. Okay, now what are the corner points? Let's find. One is 0, 0, okay, 0, 0, and this point, that is 4, 0, and this point we have to find, see it is the point intersection of these two lines, right? So by solving these two equations we will get x and y values, that is this point, okay, and this point 0, 4, okay. Let's find this point, that is 3x plus 2y is equal to 12 and x plus 2y is equal to 8. Okay, let's find here x is equal to, solve these two equations. X is equal to 8 minus 2y, substitute this 8 minus 2y here. So 3 into 8 minus 2y plus 2y is equal to 12. 24 minus 6y plus 2y is equal to 12. That implies, take this 24 here. Okay, so minus 6y plus 2y minus 4y is equal to minus 12. That implies y is equal to, minus cancelled, y is equal to 3. Okay, so y is equal to 3. Next substitute y is equal to 3 in any of these equations to get x value. So here put y is equal to 3 here. Okay, substitute y is equal to 3 here. X plus 2y is equal to 8. Here put y is equal to 3. So x plus 6 is equal to 8. That implies x is equal to 8 minus 6, 2. Okay, so this point is 2, 3. X is equal to 2, y is equal to 3. So it is the point 2, 3. Now let's find at which point this z is minimum. Okay, so corner points, first of all 0, 0. Okay, first point 0, 0. Z is equal to minus 3x plus 4y. Okay, so what is z? 0, right? When substitute x is equal to 0, y is equal to 0, z is 0. Next point, let's take, it is 4, 0. Okay, 4, 0. Z is equal to, substitute x is equal to 4, y is equal to 0. So minus 12, right? Next, the point 2, 3. 2, 3. Z is equal to minus 3 into 2, minus 6 plus 4 into 3, 12, that is equal to 6. Next point is this one, that is 0, 4. This point is 0, 4. Okay, 0, 4. That because it is a point on y-axis, their x coordinate is 0, right? Okay, so 0, 4. Z is equal to, put x is equal to 0, y is equal to 4. So minus 3 into 0, 0. 4 into 4, 16. Okay. See here we have to find the minimum value. So what is the minimum value? Minus 12, right? So minus 12 is the minimum. At which point? At 4, 0. So here the solution is 4, 0. X is equal to 4, y is equal to 0. Okay. That is minimum value of z is minus 12 at 4, 0. Okay. Minimum value of z is minus 12 at which point? 4, 0. Maximize z is equal to 5x plus 3y subject to 3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10, x greater than or equal to 0, y greater than or equal to 0. Okay, so here also objective function and constraints are given. Objective function is z is equal to 5x plus 3y. Okay, maximize. And constraints are 3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10, x greater than or equal to 0, y greater than or equal to 0. See, here x and y always greater than or equal to 0, so no need to write the negative values in the graph, okay. So here first of all we have to draw the graph, right. So for that we have to find x and y values for each inequality. That is, first of all 3x plus 5y is equal to 15 and 5x plus 2y is equal to 10, okay. Then x, y, put x is equal to 0, what is y? When x is equal to 0, y is equal to 3, right? Put y is equal to 0, what is x? 5, right? Then let's plot the points. X is equal to 0, y is equal to 3, okay? It is the point 0, 3. Then x is equal to 5, y is equal to 0, it is the point 5, 0, okay? And join these points. So it is the line 3x plus 5y less than or equal to 15. Next is, okay, here we will find x, y. When x is equal to 0, what is y? 5. When y is equal to 0, what is x? 2. Right? Okay. So here, next we will plot the points 0, 5. When x is equal to 0, y is 5. It is the point 0, 5. Okay. And when x is equal to 2, y is equal to 0. It is the point. Okay. That is 2, 0. Okay. So join these points. So it is the line 5x plus 2y less than or equal to 10. Okay. Now what is the feasible region? It is less than or equal to, right? Both the inequality less than or equal to. Therefore, the region is, feasible region is this one. Okay. It is the feasible region. And what are the points? Corner points. See, one is 0, 0 and this point 2, 0 and this point 0, 3. This one we have to find. This point is the intersection of these two lines, right? So by solving these two equations, we will get x and y values, that is this point, okay? So let's solve these equations. 5x plus 3y, 5x plus 2y is equal to 10 and 3x plus 5y is equal to 15. Let's solve these equations. So for that, okay, so let's make 10y, okay. Let's multiply 5 here. We have to make any one of x or y, coefficient of x or y make equal, okay. Make the coefficients same, okay. So here let's make this coefficient same, okay. So here we have to multiply 5, here we will multiply 2, okay. So that is 25x plus 10y is equal to 50. And here we have to multiply 3 to make here 10y. Sorry, 2 we have to multiply 2, okay. Multiply this equation by 2 to get the coefficient of y 10. That is 6x plus 10y is equal to 30. Okay. Next, subtract these two equations. We will get 25 minus 6 is 19x. It is cancelled. Okay. That is equal to 50 minus 30, 20. That implies x is equal to 20 by 19. Okay. So next, substitute this x is equal to 20 by 19 in any of these equations to get the value of x. So here let's substitute here 5x plus 2y is equal to 10. 5 into 20 by 19, okay, plus 2y is equal to 10. That implies 2y is equal to 10 minus, it is 100 by 19, right? So minus 100 by 19. That implies, sorry, that is equal to 19 into 10, 190. 190 minus 100, 90 divided by 19. Okay. So what is y? Y is 45 divided by 90. So x is equal to 20 by 19. Y is equal to, x is equal to 20 by 19, y is equal to 45 by 19. Okay, it is the point, intersection of these two lines. Okay, after that, okay, we have got all the points, right? 20 by 19, 45 by 19. Then we have to find at which point given z is maximum. Okay, at which of these points z is maximum. Let's find one by one. 0, 0. The points. First point 0, 0. Okay. Z is equal to 5x plus 3y. Right? Then here z is equal to 0. Next let's take the point. We have taken 0, 0. Next 2, 0. 2, 0. Put x is equal to 2. Y is equal to 0. Z is equal to 10. Right? Next point, okay, let's take 20 by 19, 20 by 19, 45 by 19. Here z is equal to, substitute x is equal to 20 by 19, 5 into 20 by 19 plus 3 into 45 by 19. That is 100, 100 by 19 plus it is 15, 125 by 90. That is equal to 235 by 90. Okay. Then next point, next corner point is, it is 0, 3, right? 0, 3. 0, 3. Here put x is equal to 0, y is equal to 3, that is 9. Okay. Now which value is maximum? Z is equal to, maximum is 235 by 19, right? 235 by 19 is the maximum at which point? 20 by 19, 45 by 19. Okay. So here you should write the maximum value of Z is, maximum value of Z is 235 by 19 at 20 by 19, 45 by 19. That is x is equal to 20 by 19, y is equal to 45 by 19. Minimize z is equal to 3x plus 5y such that x plus 3y greater than or equal to 3, x plus y greater than or equal to 2, xy greater than or equal to 0. Here also objective function, minimize z is equal to 3x plus 5y and the constraints are x plus 3y greater than or equal to 3, x plus y greater than or equal to 2, x and y greater than or equal to 0. Here also we have to find for what values of x and y this z is minimum. Okay. So by graphical method, so we have to draw the graph. For that we will take x plus 3y is equal to 3 and x plus y is equal to 2. Here x and y, put x is equal to 0, what is y? When x is equal to 0, y is 1. And when y is equal to 0, what is x? 3, right? So now let's plot the points 0, 1. When x is equal to 0, y is 1. It is the point 0, 1. And when x is equal to 3, y is equal to 0. It is the point 0, 3, 0. Okay. X is equal to 3, y is equal to 0. Join these points. So it is the line x plus 3y greater than or equal to 3. Okay. And next, okay, here x plus y is equal to 2. X, y, here put x is equal to 0, y is equal to 2 and put y is equal to 0, x is equal to 2. Plot these points 0, 2, 0, 2. It is the point 0, 2 and 2, 0. It is the point 2, 0. Join these points. So this line is x plus y greater than or equal to 2. See, look at the inequality. It is greater than. Okay, so what is the feasible region? See, outside of this line, right? That is, it is the feasible region. Okay, it is the feasible region. So here, what are the corner points? See, these are the corner points. Okay, no origin. Okay, these are the corner points. So what are the points? See, first one is, it is the point 0, 2. This point we have to find, it is the intersection of these two lines, and this point is 3, 0. Okay, let's find this point by solving these two equations. X plus 3y is equal to 3, x plus y is equal to 2. Okay, let's subtract these two equations. Equation 1 minus equation 2, we will get 3y minus y, 2y is equal to 1. That implies y is equal to 1 by 2. Substitute this y is equal to 1 by 2 here. So x plus 1 by 2 is equal to 2. That is x is equal to 2 minus 1 by 2. That is 3 by 2. Okay. So here x, this point is 3 by 2, 1 by 2. Okay. So 3 by 2, 1 by 2 is also a point contains this feasible region, right? Okay. Now let's find for what value or for which point, at which point this z is minimum. Okay. Let's find one by one. First one, z is equal to 3x plus 5y. First point 0, 2. Okay. 0, 2, substitute x is equal to 0, y is equal to 2, that is z is equal to 10. Okay. Next point 3, 0. 3, 0. Z is equal to, here put is x is equal to 3, 9 plus 0. Okay. Then next point is 3 by 2, 1 by 2. Okay. Z is equal to, put x is equal to 3 by 2. 3 into 3 by 2 plus 5 into 1 by 2, that is equal to 9 by 2 plus 5 by 2, that is 14 by 2. 14 by 2 is nothing but 7. Okay. So here which is minimum? Say minimum value is 7. 7 is minimum. Okay. So here z is minimum at the point 3 by 2, 1 by 2. Okay. So here minimum value of z is 7 at which point? 3 by 2, 1 by 2. That is x is equal to 3 by 2 and y is equal to 1 by 2. Maximize z is equal to 3x plus 2y subject to x plus 2y less than or equal to 10, 3x plus y less than or equal to 15, xy greater than or equal to 0. Here objective function maximize z is equal to 3x plus 2y and the constraints are x plus 2y less than or equal to 10, 3x plus y less than or equal to 15, xy greater than or equal to 0. Okay, to draw the graph we have to find the values of x and y. X plus 2y is equal to 10. 3x plus y is equal to 15. So here x, y, first of all put x is equal to 0. When x is equal to 0, y is equal to 5. Then put y is equal to 0, x is equal to 10. And here x, y, first of all put x is equal to 0, y is equal to 15. Then put y is equal to 0, you will get x is equal to 5. Okay. Now let's plot the points. First of all, here 0, 5. When x is equal to 0, y is equal to 5. Okay. So it is the point 0, 5. And then x is equal to 10, y is equal to 0. X is equal to 10, y is equal to 0. It is the point 10, 0. Okay. Then join these points. So it is the line x plus 2y less than or equal to 10. Okay. Next this one, when x is equal to 0, y is equal to 15. When x is equal to 0, y is equal to 15. So it is the point 0, 15. And x is equal to 5, y is equal to 0. It is the point 5, 0. Join these points. So this is the line 3x plus y less than or equal to 15. These inequalities are less than, right? Therefore, the feasible region is inside this line. That is, it is the feasible region. And this feasible region contains the points, this origin and the point 5, 0 and this intersection point and 0, 5, right? 0, 0, 5, 0, 0, 5, we have to find this intersection point. It is the point of intersection of these two lines. So by solving these equations, we will get the values of x and y. 3x plus y is equal to 15 and x plus 2y is equal to 10. Okay, so from this let's find x. That is x is equal to 10 minus 2y. Let's substitute this x is equal to here 3 into. To find the values of x and y, see here any method you can apply for your convenience. Okay, 3 into 10 minus 2y plus y is equal to 15. That implies 30 minus 6y plus y is equal to 15. That implies, take this 30 here. So here minus 5y is equal to minus 15. That implies y is equal to, minus cancelled, y is equal to 3. So y is equal to 3. What is x? 10 minus 2 into 3, 6. That is 4. So here 4, 3. It is the point 4, 3. X is equal to 4, y is equal to 3. 4, 3. Now let's find at which point the z is maximum, right? At which point z is maximum. Z is equal to 3x plus 2y. Okay. First point 0, 0. Z is equal to 0. At 5, 0. What is z? Put x is equal to 5. That is 15. Y is equal to 0. Okay. Next 0, 5. Z is equal to 0 plus 10. Next 4, 3. Put x is equal to 4. Z is equal to 3 into 4, 12. Okay. Plus 2 into 3, 6. That is 80. Okay. So which is the maximum value? See, maximum value of z is 18. At which point? 4, 3. Okay. Therefore, maximum value of z is 18 at 4, 3. Okay. At the point 4, 3. Minimize z is equal to x plus 2y subject to 2x plus y greater than or equal to 3, x plus 2y greater than or equal to 6, xy greater than or equal to 0. So you have to write objective function minimize z is equal to x plus 2y and constraints are 2x plus y greater than or equal to 3, x plus 2y greater than or equal to 6, xy greater than or equal to 0. Okay. So here we have to find for what values of x and y z is minimum, right? At which point z is minimum. Okay, so for that we have to draw the graph. So here let's consider these two inequalities. 2x plus y is equal to 3, x plus 2y is equal to 6. X, y, first of all put x is equal to 0, what you will get? Y is equal to 3. Put y is equal to 0, what you will get? X is equal to 3 by 2, right? Then x, y, here also put x is equal to 0, y is 3, put y is equal to 0, x is equal to 6. Now let's plot the points. 0, 3, 0, 3 is this point, right? So it is the point 0, 3. Then 3 by 2, 0, x is equal to 3 by 2. See, somewhere here between 2 and 3, okay? 3 by 2, let's take it is the point 3 by 2. 3 by 2, 0 is this point. Okay, then next inequality, that is 0, 3. Okay, 0, 3, the same point. It is 0, 3 and 6, 0. 6, 0. It is the point 6, 0. Join these points. Okay, so it is the line 2x plus y greater than or equal to 3 and it is the line x plus 2y greater than or equal to 6. Okay, so here look at the inequality. It is greater than, right? So here the feasible region is outside this line. See, it is the feasible region and this feasible region contains only 2 points, that is corner points 0, 3 and 6, 0, right? Okay, now let's say at these points what is the value of z? Okay, so here points z is equal to x plus 2y. First 0, 3, z is equal to, at 0, 3, z is equal to, put x is equal to 0, y is equal to 3, z is equal to 6, right? Then next point 6, 0, here z is equal to 6, right? Okay, here we have got 6 is the minimum, right? Minimum value of z is 6, and here there is no common point with this feasible region, right? So here we can say this z is minimum at the point on the line joining the points. See, these are the joining, this line joining the points, right? 0, 3 and 6, 0. Okay, so here we say z is minimum, minimum value of z, minimum value of z is 6 at the points on the line. See, the point somewhere on this line, okay, on the line joining the points 0, 3 and 6, 0. Okay, so here the minimum value of z is 6 at the points on this line joining the points 0, 3 and 6, 0. Okay,